What's up, guys? For you, I'm going to be talking about your final prep review part 12 question. And this question is estimating using a left-hand Riemann sum with four subdivisions. The function is 2 plus cosine of x, and we're evaluating it from 0 to 2 pi. We also want to be able to determine how far this estimation is from the exact answer. In this video, I'm going to be using the TI Inspire predominantly, and I'm going to start by graphing 2 plus cosine of x. I thought it'd be kind of nice to actually restrict the domain. I tried something that works on Desmos. I tried typing the less than x less than. It didn't work. So here's a little quick montage. I checked the video out, and you can always Google anything, beyond whatever it is. And I learned that there's a symbol that says such that. I mean, I knew that such that existed. It's part of set language, but I also learned that it works for use here. You type the such that, and then you go your limits to restrict your domain. And in this case, I'm getting from 0 to 2 pi that first, only that one cycle of a cosine function with amplitude 1 and midline 2. Quick sketching it, horrible sketch, I realize it's gross. But in the quick sketch of it, I'm just going to kind of jot down some of the key features. Like the cycle has, the length of the period is 2 pi, and there are 4, maybe 5 if you count 0 places where the function is definitely doing something. A left-hand Riemann approximation means you use the left-hand side of each interval in order to determine the height. That second and fourth rectangle should be the same because they technically are hitting at 2. Because cosine of pi over 2 is 0, and cosine of 3 pi over 2 is also 0. So they should be hitting at 2, but that's the way that I drew it. Just to determine, how I know that the answer is 3, how the height of each rectangle is 3, then 2, then 1, then 2 again. We're just evaluating. We're just plugging in that x number into the function. So 2 plus cosine of 0 is 3. 2 plus cosine of pi over 2 is 2. 2 plus cosine of pi, well, let's see, cosine of pi is -1, so 2 minus 1, really. So we have 1. 2 plus cosine of 3 pi over 2 is also 2 plus 0. So these are really related to where we are at cosine on the unit circle. So, being 1, 0, -1, and 0. With that information in hand, a left Riemann approximation with 4 subdivisions is going to take each of those heights, 3 plus 2 plus 1 plus 2, since the width is consistently pi over 2, the same for all of them, and we just multiply them out. So I'm going to go 3 plus 2 plus 1 plus 2. I can do that math in my head, so let's just call it 8 times pi over 2. I can do that math in my head. It's 4 pi. 4 pi, the approximate area under the curve using a left-hand Riemann approximation sum is 12.566. In order to determine how far that value is from the estimate, let's just go ahead and evaluate it. TI Inspire has the integral feature. We can evaluate definite integrals with our calculators, so just evaluate the integral and subtract by the approximation, and that answer will be what we call our error. How far off are we? I mean, this happens all the time with engineering and with trying to determine, what extent, how detailed does our work have to be. And so if we can get away with a simpler trick instead of going through the full detail of a problem, let's do it. Anyway, thanks for watching this video. Hope it helped out. Remind you about those LRAMs, RRAMs, and MRAMs. Maybe you should go back and do some more studying up on that stuff. Thanks for watching this video. Thanks for doing some math with me. See you in the next video.